Welcome. This is a continuation of a previous video where we compared random forest, logistic regression, and gradient boosting. Went through a slide deck, and this is where we're going to actually put that into some practical use. Right. So in this Jupyter notebook, what I'll be doing is going through and testing out these three different model types on the Titanic Dataset, right? So predicting who survives, who does not survive, right? And we're just going to compare accuracy. We're also going to look at the confusion matrix and see what some of these outputs look like when these are actually ran right up against each other, right? So I'm going to start with bringing in all my libraries. I'm going to read in my data set, and you can see here I've got items such as passenger ID, survived, sex, age, fare, right? This is a fairly standard data set that comes with these fields. If you go on Kaggle or in my GitHub repository that I'll attach to this video, you can find this data set. Now we're going to next define our X and our Y. We're going to drop passenger ID and we're going to drop survived passenger ID because it has to do with, it's nothing that's actually predictable, right? There's not an ID that's going to say this person was in this region of this ship. It's just an identification number, kind of like an individual social, right? Nothing particular puts that person in a grouping, right? We're going to drop survived from our X because that's actually our target, and then we're going to look at the shape and the columns. So ran that. Now we're going to go ahead and do our test train split, and then we will make our logistic regression pipeline, right? So we use our pipeline. We're then going to scale these fields so that they are all on a similar plane, and then we are going to use our logistic regression model. Then we go ahead and we fit this to our X train, our Y train, and then make predictions on our X test, and then do an accuracy score of our Y test, what the actuals were versus our predictions. And then we are going to print out our accuracy and then do a classification report against our Y test and our predictions, right? Go ahead and run that. We can see, okay, so our accuracy is one item that I said we'd be comparing, right? So we're at 0.80. So that's one item we're going to be comparing, and then we're going to be looking as well at random forest. We're going to do a max depth of 5, so 5 trees, 5 layers down, right? Let's go ahead and run that. And we're doing a similar task, right? So we built our random forest classifier. We're doing a fitting, our predictions, accuracy scores, and then making our classification report. And so that brings us back with a 81%. Now we're going to do our XGBoost classifier and do the similar task, right? So we're going to do our fitting, make our predictions, get our accuracy score, and then make our classification report. And we can see, okay, we got 82%. So based off of just accuracy alone, we can see that logistic regression fared well at 80.5, and then random forest at 81.7, and then accuracy of XGBoost at 82.3. Right? Now we can look at our results, compare them, just like I just stated, right? So our best performer based off of just accuracy was at XGBoost, then random forest, and logistic regression. And then we can plot our bar chart where we literally just say, okay, what's the comparison in bar chart form of XGBoost, random forest, and logistic regression. So just a visual that we're putting to what we created above here with this data frame. Then we can do our confusion matrix display. Where we say, okay, our true predicted of did not survive, and so we predicted they did not survive, and they actually did not survive. It was 84. Our predicted of did not survive, and they actually did survive, was 17. Right. So that's kind of how this reads. our predicted did survive and they actually did not survive was 14. So whenever we're looking at survival and did not survive, that's a fairly important piece here, right? So whenever we look at just that alone, I would honestly go as far to say that we predicted they would survive, but they did not survive 10. This would be our better performer, and that being because we want everyone to survive. We want to be overly cautious that they will survive, right? Now, these ones, sadly, we can't help the ones that did not survive, but we can help the incorrect predictions, right? We can help that being solved for, right? So these 10, I would like to see that be minimized and moved into a true bucket. So either into our predicted label of true or false true. Right? And we can see our XGBoost, what that looked like as well. Right? So that actually was one more than our random forest, but had one less in our predicted did not survive, and they actually did not survive. So 87 compared to 88. Right. And that very well could be that added one that's right here. Okay. Now, if we are looking at feature importance on a comparison scale, and we're looking at random forest compared to XGBoost, we can see that for random forest, the column or the field sex 1, and we can see that's by 0.32 in terms of performance or importance percentage. And then same thing here with XGBoost, it was at 0.28 this time though. Okay. And that's the end of this video. Just wanted to get on show the difference in these models, some of their performance at a very base level with the Titanic Dataset that can be found on Kaggle or really any of these data science competition websites, and go from there. So I'll look forward to seeing you on the next video. Thank you.